Okay, so starting the video and let's carry on. So I've also connected to my environment in the so in the environment I'll just 2 GB first machine, resume, 14 GB second machine, resume, and 4 GB third machine, resume. I'll let it resume all, and okay, so it's resuming right now, and in last class we talked about virtual standard switch, and we talked about how to create what are port groups and how do we create them. And let me just go through that. 19. Okay, regular ones. I'll just add what we need to do today, and there's very interesting labs coming your way. Let's do it. Show source pools. So we talked about that VApp. So resource pools just to reserve CPU and memory, VApp to group together and reserve CPU and memory both. And yeah, then virtual machine management. We talked about templates and how to create a template, how to create a clone from a template, how to what are the precautions for these? Do templates start or not? So other than that, we talked about the golden image. What is golden image, and how do we in a critical environment you can create a lot of you can get a lot of machines ready with the help of golden image, which is like a perfect machine. Some of you already have done that or are doing that in your job environment. Others, you will see that in a typical company, yes, they have to do this. Also, handling all the devices through cloud. So that's actually Microsoft Intune or any MDM solution. Anyone needs free access to that course, let me know. I just recently finished that. You should know how to handle thousands of devices from cloud. So anyway, this is the import OVF, OVA. There's a difference between OVF, OVA. OVA has one file with all the machine imported. OVF actually exports with 4 files. And so we did the lab for that as well. And then we talked about virtual standard switch. So it gets created in every new installation of the hypervisor. And obviously it provides networking to the virtual machines. We talked about then there are 2 components of port group and VM kernel port. Port groups are used to provide networking to the virtual machines so they could connect to each other and to the outside world, while VM kernel port provides networking to advanced features. And one of the features we're going to try today, we're going to be in vMotion or migration of virtual machines from one hypervisor to another, but we were still talking about virtual standard switch. And there are lots of features. So yeah, this I don't need to delete this one because we're still talking some more about virtual standard switch. And then we're going to go for the migration topic. We're going to migrate virtual machines from one hypervisor to another and back and forth. So virtual standard switch, VMs only see port groups. Yeah, we talked about that. Now this is in the last slide as well. So Do I keep it? Yep, because that's the same topic. What ports need to be open inside the firewall for vSphere? So there was a question in last class. So this is the information. I'll delete that for this slide. And yeah, download that provide. So that's just download links. I'm going to continue with the virtual standard switch topic. So some of it was remaining, and what was it? Let's talk about that. Then we're going to go for migration. Hopefully, we could start distributed switch as well, which is another long topic, and grand power switches, VMware environment. Okay, so remember that we were talking about the virtual standard switch. If we go to the diagram, I'll grab a diagram where I have depicted the switch. So in this diagram, these are suppose these are V switch or virtual switches, right? So we created multiple port groups in last class. We created multiple virtual standard switches in last class, and we moved virtual machines from one port group to another port group. Uh, okay, so Chris says in the chat, is there any solution to the VTX error? Well, I did ask VMware guys. In fact, that's a very good question you put up. I was going to talk about it at the end of the class. Um, so there's a reply actually from VMware today. Before I was just about to, well, a few hours before, and that was that. See this? There's a version. So question. I hope everyone understood. So is there a solution for VTX? Now, issue. So I had sent that to VMware. So VMware says that we are running version of VMware, which is update 1. So this is 7.0, which is good, but it's update 1. There is update 3 as well. So I don't think that upgrading to update 3 would solve it, but it could. Although I could not find on VMware documentation itself and any of the groups outside sharing their experiences. So no one said that upgrade this, but it could be possible that this vSphere 7 update 1 that we are using, instead if we use vSphere 7 update 3, so that we can try and install, and they say that go ahead and try that. Instead of saying that install that and yes it's gonna work, they say that go ahead and try that. So um, this means that we need to download and install 7 update 3. And okay, so how about one more thing here is if I go for, so I'm gonna go for this. I'll just drag a tab here, and here, so download VMware vSphere 7, update 1, update 2, 2A, 2D. There's update 3, and then there's 3F as well, actually. So if I go for 3, download VMware vCenter 7, update 3, right? You guys could try that too. And in fact, let me know you're able to do that. So download VMware vCenter. I'll use this package. If I go to customerconnect.vmware, get download. Any of you are able to do that. So I'm gonna send that link. Oh, there's download 3. So if we go for download now, it take me to where? Serious. Okay, guys, I'm putting a link here. Please click this. This is just the link that I tried to open. And some of you, if you could actually dig down a little, please try to download vSphere 7 update 3, and let me know if you are able to with your free user account in vmware.com. Actually, it's customerconnect.vmware.com. It takes me there. So if any one of you, actually pretty much all of you should be trying this, because what's happening to some of you could happen to all of you as well, with later versions. It would be better to really test that and download it. Um, so what I was expecting was that they would give me the download link as well, but then they that just download it now. I tried to download before as well. Then I sent that email to them. Hey, can you just provide me the download link? Any of the students, you're able to download the links that I've sent you, or any other way if you can go for VCP7 update 3, because it's a free trial version, right? So free trials are normally supposed to be available. Uh, some websites also keep a version of that free trial with them, so it could be searched there. Other than that, I'm going to be trying this night, to or this by this weekend. I'll try to download it. I have called up some friends who are interested, and I have asked them if you could just download the trial version for us from your customer connect. So whatever I could find, so we could install that, especially the vCenter, and I'll try this in the laptop. So this weekend we can try that. So that's a good question you brought up, Chris. It's good that you're still, everyone is worried, but it's a good reminder. So I'll be following up with you guys if anyone gets lucky and gets the 7 update 3 version for vCenter and hypervisor both. Otherwise, I've asked some of the friends already, so I'm just waiting for the reply. They could send me a download link. When you go to the VMware.com website itself for trial version, they are going for now vSphere 8 trial version. This is a totally new certification. So obviously 7 would still be around for 2, 3, 4 years. You're good, you're safe. But also vSphere 8 is not a big difference. Some new features are there. So, but it's based on many of the features of 7. Actually, 7 is based off many of the features of 6.0 as well. So it's always a slight difference, or nothing core architectural difference between 7 and 8. The trial versions of 8 have been added there in the VMware.com site. Okay, so guys, we're gonna try to resolve that. Hopefully, I'll be doing that this weekend. If I get any downloads from my friend side or from VMware side, I've also asked that, so we will try that. And any one of you who gets to download that, just share with us. We could all try in our laptops, especially those who are having VTX version, including my laptop. Also, I'm having a VTX. So, well, that's a slight direction to the solution. Hopefully that works. And guys, there's 8 version as well. We could actually try to download and install the vCenter 8 as well. But obviously, I have to repeat all the labs there just to make sure that what's the difference, and obviously that is something that I would need for. That if there is something different that I have to first test instead of directly introducing in the class. Mainly those features I've been teaching since 6.1, 6.0, the features that I'm about to show all. So 6.0, 6.5, 6.7, 7.0, it's pretty much the same. Major features are all same. Okay, so I'll go back to this after providing those links there.
Hello.
And
Yeah, I have shared my screenshot on WhatsApp.
yeah,
Uh, in virtual, this in VM network, instead of virtual machine 3, I have one virtual machine.
server virtual machine 3. Three virtual machines, you have one virtual machine.
Yeah.
So did you click this, this option? You're seeing something on the left side?
No, in VM network means in virtual switches.
Virtual switches. Okay.
Yeah. In that second one
Oh,
is
okay.
VM
So you're
network.
comparing with mine.
Yeah.
You're seeing one virtual switch. I have actually two here.
No, no.
So you have to
Actually,
just
two switches. In first switch 0
port group,
in VM network.
port groups. These are port groups.
Yeah, yeah. Port group. Yeah.
So
Port
you're
group.
seeing one port group instead of two, or as many as I
No,
have.
no. In second one VM network, that is in there instead of three VM, I have one.
Oh, okay. This virtual machines
Yeah,
here,
yeah.
that is okay. I mean, we moved some virtual machines from one port group to another. The main thing was uh, to know that how to move virtual machine from one port group to another port group. So if there's one or there are three, it doesn't matter. It's okay.
Okay, okay. No problem.
Okay.
Thank you.
Got it. Got it. Guys, so let's get back to this, and obviously we will be also trying that vSphere. I don't want to jump to vSphere 8, but if it's not totally different, I'll try to install it in this environment, my laptop. But I'll let you know that what if new laptops accept new version of vSphere. Okay, so let's go ahead and but even in the new version, these major features will be the same. So we need to understand all these major features. So as I was talking about this virtual standard switch, so you have to understand the virtual standard switch internal mechanisms as well. So about that, so we switch, uh, we switch and port groups do switch and port groups um, features. Okay. Now there are many configurations inside the vSwitch and port groups. So those configurations are very important in terms of security, high availability, disaster recovery, monitoring. So if we go back to okay, these features are related to disaster. It's to high availability of inbound, outbound data, um, and monitoring security of data uh, coming and leaving the switch. So that's how it is. Let's go discover that where it is. And I'm going to go back to this environment and here. So I'm going for E682 or E683, whichever. Configure virtual switches and then this virtual switch. So we have two virtual switches. We already know that. Switch 0 has certain port groups and yeah,
Refresh the page.
so um, here, if you go to the virtual standard switch here, there's an edit button here, right? So if you click the edit button, So you see here that we can go inside. The voice is not clear. Is that for all you guys? So guys, is my voice clear or not? Everyone, is my voice clear? Okay, so Sintra, Chris says it's clear. Nathaniel, my voice is clear. I think you can check your internet connection. Pragnesh says the voice is clear. So okay, guys. So I'm gonna go ahead and I've opened that. I've the edit button and the inside of the switch I'm expecting to see, but okay. I'm expecting to see the inside of the switch. I think why it's not showing because I froze that screen. I should be kicked out and then I should kick myself in or log out and log in. So I refresh that and you can see advanced and this. Okay, so first we're gonna log in from administrator at vsphere.local and once we're inside, so it should when I click at it, then it should be. So I'm just gonna go for 6i2 virtual switches, edit, and then so once we click edit, you can see this properties, security, traffic shaping, and failover. So this is properties or settings inside the virtual standard switch. So it's not a like a blind switch with just data incoming and outgoing without any kind of controls inside. So it has a lot of features to pretty much control the data going in and out. So if so number of ports is elastic. So first of all, it says, and elastic just means that automatically it's going to suppose there are 10 virtual machines, right? So as soon as the 10 virtual machines are connecting, they will be provided connectivity over the ports. So elastic just means automatically ports be provided the virtual machines and with the help of port groups. Okay. MTU, maximum transmission unit. So this is just the payload size of the packets. We normally don't really touch it unless we have a good reason for that. Other than that, there are security features here: promiscuous mode, MAC address changes, and forged transmits. So promiscuous mode is that if you want more diagnostic data to be captured, so you could know, suppose there's an issue in the network and people are saying, hey, when I'm sending my email or when I'm sharing my file, it's either very slow or it's not really working or it's just unacceptably slow at certain time. So you would just change that to promiscuous mode and it will then release some diagnostic data from the switch as well for about all type of traffic that is passing from that switch, right? So if you enable it, accept it, then it will just simply release more diagnostic data. You can capture it through a sniffing tool called for example Wireshark, which is very famous. You can just capture data there in Wireshark and then try to check that what's wrong with or what's causing all the delay in the bandwidth or the data in transit or the data on the move. Then there is MAC address changes and forged transmits. So these are just more protection tools. So MAC address changes. MAC address normally changes for a virtual machine. Now, first of all, virtual machines are the hypervisors provide MAC addresses because these are not physical network interface cards. These are virtual right, or network interface card. So they have to be provided MAC address from somewhere. So hypervisor provides them, and if it tries to change the MAC address, normally MAC address changes they happen when there is load balancing going on, and there is multicast load balancing, then there's broadcasts going on the load balancing. If there's a load balancing software, and then there's unicast as well. So what happens is that virtual machine tries to hide their MAC addresses, and just one MAC address shows the outside switch. So this is something for specific scenarios that you would change. Otherwise, mainly the administrators don't change that at all. Force transmits as well for some scenarios, for some applications. Again, it's there's an example of load balancing that if there are forge transmits, or there are transmissions coming from some machine that is pretending to be some other machine. So in that case, reject those that kind of data as well. It's not coming from the original source. And if it is pretending that, hey, I'm actually that PC, while it is not that PC or that source of data, so it's going to just reject those as well. Now, these are the scenarios that these are the options that normally administrators don't touch. If you ask VMware administrators, hey, did you configure anything? So yeah, sometimes diagnostics we have to do that. Otherwise, we haven't touched these options. They don't need to do that. They're there for specific scenarios. Traffic shaping. It is important to. So suppose you have a lot of data going between uh, 10 a.m. and 2 p.m., right? So you see that there's a lot of data, inbound and outbound data going and coming to and from virtual machines. So the thing is that you want to cap it. So you can enable that option that, okay, data should not be, or bandwidth should not go more than 100,000 kilobits per second. Right? So average bandwidth would be 100,000 kilobits per second, and peak bandwidth 100,000 kilobits. So if you enable that, it's going to put a cap on the bandwidth, and it cannot go more than 100,000 kilobits per second. But if you disable it, obviously, and it's going to be unlimited, and it's going to go much more than this. So hopefully your uh, network really supports more than this bandwidth during peak hours, especially. Burst sizes, that bursts of data passes through the virtual standard switch. So how much burst, or just like you would have a burst of rain, and there's a lot of rain comes, and then it slows down, and then another burst of rain comes, a heavy rain comes. So the burst of data if it comes this way, then how much burst of data, what is the size of the burst that this virtual standard switch should support and should let go? If you enable that, then this is the size, and it's not going to let any more data pass. It's going to block that data, or the data it's going to drop the packets unless you want. If you disable it, then it's just whatever size of burst, and you just really hope that hey, you have your networking or your cabling. If you have fiber optic, then it's you're not to worry. It supports a lot of bandwidth, but if it's Ethernet cables like Cat5, Cat6, Cat6E, maybe Cat7, so those kind of Ethernet cables, then you should worry about that and check that with monitoring tools that if you need to cap or stop or control the bandwidth, how much data passes and how much data should not pass after a certain limit. You can do traffic shaping on virtual standard switch level. And then there's teaming and failover. So there's that load balancing. And in the load balancing, you have four options here. So route based on IP hash, route based on source MAC hash, there's route based on originating virtual port, and then use explicit failover order. So what that really means in English is, okay, I've started annotating. Okay, so route based on IP hash for load balancing. So what does that all mean really? So there is that, suppose there are virtual machines here, And there's that. So these are VMs, and then there is a switch, and that's suppose a switch there. Actually, that's a network card. So suppose you have that's a switch, and then there is that. Oh, and I'm gonna change this. It still keeps grabbing it. So there's a switch. Then there are NICs there. So NIC 1, NIC 2, NIC 3, NIC 4. Suppose there are network cards there, right? And this is whole hypervisor inside which there are network. So these are NICs. So what happens is that whatever data is passing, route based on IP hash just means that day one, suppose whenever the virtual machine was created and it started sending data to the switch, and the switch said that, okay, hey, network card 2, why don't you take the data? Then network card actually remembers that this the IP address information of the machine, and then next time whenever this machine sends data through the switch, it always goes through that network card unless it is overwhelmed, and then the data is transferred or moved to the other network card and load balanced. So this is IP hash based, um, detecting of the source of data. And then there's a source MAC hash. This just means that suppose the virtual machine sent data the first time, switch said that, okay, hey, you network card, you can just take this machine's data. And you have configured it on MAC hash base. So this means that MAC address information of this machine will be saved for the network card. Every time that this virtual machine sends data, it will go through actually this network card unless it is overwhelmed, and it's going to share that traffic with other network cards. Then route based on originating virtual port. So suppose any of the machines, or suppose this machine sent a data and the network card says, oh, virtual start switch says, hey, you're going to take that. Suppose it just remembers that virtual port, originating virtual port of the virtual machine. So the virtual port is just in a port group. There's a virtual port that the machine connects to, and then that port is remembered. Oh, from this port in the port group of virtual switch, this machine sent me data, so I'm gonna always receive from this machine unless it is overwhelmed with data and it shares the data with other network cards in load balancing manner. So then comes the explicit failover, and that is that the suppose a virtual machine in any one of those four virtual machines send the data to the switch, and it sends the data to any network card. Suppose this one. If now the data will keep going from this network card, but it could be any data. This is explicit, right? So this means that actually data coming from any virtual machine goes to the network card, and if this network card has any issue, so then it will share the data, or if there's overwhelming data coming from to this network card to and from, so it's going to share that automatically with the other network cards without any specific identification of the virtual machine or virtual port. So this is just a way to load balance the data by identifying the source of the data. And then, so you can just, by default, it just detects that which virtual port of the virtual switch the virtual machine is connected to, and it just starts receiving data from there. And if it's overwhelming data, then it's going to share with other network cards. So that's overall with the load balancing that we're talking about. I'm just going to put that here, and so as virtual switch features, and then we go for, yeah, then the next one is network failure detection. So obviously you need to detect failure of the network to which you're about to send data or you're about to receive data from. You need to know if the network that you're connected to is up or down, right? So for that, okay, so I'll go for pencil sign here. And so link status only, which means that, so suppose this is a full hypervisor, there are virtual machines inside hypervisors, and those virtual machines are sending data outside. Suppose that's a network interface card, um, network interface cards. Yeah, they like samosas, right? Anyway, so here, interface cards, and you're showing this link status. So what is link status? Link status is that suppose you have a physical switch here, right? So that's a phi switch, SW switch, and you're connecting to that physical switch through the network card here, and this network goes down. Now this network card is also connected. Maybe you're smart, and it's not maybe, I'm sure you're smart, and you have two switches, a backup switch here as well, and to that SW, you also have the other two network cards connected, or this network card is traffic is going through the connection here as well, right? From the same hypervisor to other network cards connected to the other physical switch. So link status will tell you that what is the status of the directly connected uh, network card directly connected to the physical switch. So physical switches, this link is down, this link is up, the information will be then updated here, and data will not be sent to these network cards, and it will be sent through these network cards because the status is reported already, and the data will be sent to this network card. Then about the beacon probing. So in beacon probing, what happens is, so you have suppose extended switches, right? So you have here extended physical switches. Well, select this. You have extended switches. So there are physical switches that are connected to other physical switches, right? So there are more physical switches here, and these switches are connected to these physical switches, and this is also connected to this one, this is also connected to this one, and this is also connected to this one as well. So in case there's a failure, right? So what happens is that beacon probing actually starts probing the extended network, and if it reports that, okay, the connection here directly to the switches is okay, this switch is connected to certain other switches which are actually having a link down. So please don't send data to this switch because it may be okay from card to this physical switch, but it's not okay after that. But that switch still has actually a connection to this one. So yes, some ports of that uh, are going to be not working because the link is down, but through some ports it's working. So send through those ports, and the other switch is up already, and the extended network to those switches is also up. It's okay to send to all ports on this switch. Beacon probing just gives you a report of extended network. It is up or down, right? So if so if we go to then the next one, and that is failback. Failback we may have talked about before as well, that if this adapter, these two adapters are right now active, so they are both receiving and sending traffic, and they are in a load balanced mode. So failback just means that suppose this adapter is actually not available, it went down, it is not working for some reason, and not receiving traffic. So this means that the traffic failed over to this adapter. So now failback would be ideal if one adapter was on standby and maybe two or one are active. So this is just one adapter, suppose active right now. And if this adapter had some issue and it failed. So obviously then this adapter becomes the active adapter because it was standby. And as soon as it detects that the active adapter is gone, so it's going to standby will become active, right? Then this doctor comes back. Right? So do you want to, this doctor is okay now. Do you want to fail back the traffic to this doctor and again put the standby doctor, which was before standby and currently active, going to put that back to standby? And previously, which was active and then crashed and then came back again, do you still prefer to send traffic to this adapter and keep the two doctors in the previous state before the crash state? So then there's a yes here, fail back, yes, fail back to the previous state. If you put no, then the standby doctor, which had become active because of crash, will stay as the active doctor, and even if the crash doctor comes back, it will automatically become a standby doctor. So it's just fail back to the crash doctor that has now come back. You want to do that to you. Now, in this, some administrators go for no, some administrators go for yes. Those who go for no, they would have a reason that, hey, now it's kind of unreliable because it crashed, suppose. So even if it comes back, I would just put it on standby, and the one that was on standby and now active, keep it on active because this one might crash again for any given reason. Maybe that has some physical issues there, or it would it just crashed once and it would be working all the time. But if it's a bit more unreliable, I would not fail back to that. There's another reason for that. So I'm just giving you some reason there, right? So you should be just having all those factors in the mind when you're going for configurations. So that's failback, and yeah, these are the features: notify switches and notify switches. Yeah, so this is obviously if there is any issue, notify switches. So I would not go for no, obviously, but keep it yes. So these are the four options here that are inside the virtual standard switch. I didn't change any options. I'm just going to cancel out from here. So that was the virtual standard switch. So it's not just a blind switch. It has actually more security, availability, and probing or monitoring features as well. But if we go down to the um, port group level, so this is port group 1, this is port group 2, this is port group 3, and the main purpose of port group is to provide networking to virtual machines, right? Now, if I go to any port group here, so suppose I go for this one, they all have the exact same conversion. So if I select that, and then I go for the three dots here, and then there is edit settings here for the port group, any typical port group. So that also actually shows me properties, security, traffic shaping, teaming, and failovers, same as the standard switch. Another thing is that you can just change the name here. In standard switch, you had here MTU option. Here on each port group level, you have VLAN ID option, right? So one port group could be different VLAN, and the other port group could be a different VLAN. So in that case, the virtual machines of VLAN 2 based, suppose port group would be not able to communicate with the virtual machines of VLAN 3 based group. So if the VLAN numbers are different, no communication. If VLAN numbers are same, there is communication, right? So this you can configure on VLAN level. Then there is security. It's the same thing, but now you see override options here. So whatever you configure on the standard switch level, they propagate to the port groups, right? Unless you want to override any of the options. So traffic shaping also override, teaming and failover also have override options. It's pretty much the same options that you can override on the virtual port group level. So we don't need to discuss all these options, but we need to know that at least that what's the difference of the settings between a port group level and a switch level. So when you configure on the switch, it gets propagated to any new port group that you create. But suppose in this port group, all of the port groups are following the settings that are on the virtual switch level, but this particular port group, suppose you go inside and want to change the setting. Maybe you want to change the VLAN ID there. So virtual machines of this port group can't communicate with any virtual machines of the other port group on the same switch, right? Or you want to just cap the bandwidth of all the virtual machines that are connected to just this port group but the virtual machines of other port groups can send whatever data they want. So suppose virtual machines of this port group are actually test virtual machines. You don't want test virtual machines to be sending large data, and there are critical virtual machines connected to other port groups need to send that data during peak hours, right? So you can just override any of the port group level settings as well. So port groups are very powerful. They're just not offering only networking connectivity to virtual machines. They also have all the other security, balancing, and monitoring features each port group has. So port groups are also powerful as well as virtual standard switch. On a blind switch, you can actually do all the configurations in a standard switch level as well. That's what I wanted to discuss in the last class for standard switch. And that also concludes the topic of standard switch. But then this next topic, which totally depends on, well, obviously the standard switch has to be there for the migration to occur. Right? So migration cannot happen if the standard switches are not there, obviously. So the next topic, obviously, and all the next topics totally depend on if the networking is perfectly configured. Now, first thing, before we move to the next topic, we need to kind of clean up this, what we created before. Like, we don't need a lot of port groups here. Like, one port group is okay. I just created other port groups just to show you how to create port groups, right? Also, we have another extra switch here, vSwitch1 in ESXi2. We don't need that extra switch because we're going to be creating extra switches for some other advanced features. Not right now. What we're going to do is, that's, okay, let's explain here. So, vMotion, which is virtual machine and storage, and VM storage migration. VM storage migration. So let's discuss vMotion feature. And because of this feature, VMware in the early days got famous because it was offering virtual machine to be migrated live while users are actually connected and working on the virtual machine. So that was pretty cool. Now let's discuss virtual motion feature, but before this, let's remove the two extra port groups on vSwitch 0 in ESXi02 and delete vSwitch1. So once we clear that environment, then we will talk about vMotion. So in order to go ahead with that, okay, I'm just going to go back here, and we need to simply delete, first of all, the standard switch 1, because switch 0, obviously, we need it, and it's not going to let us delete as well. But standard switch 0, we need to delete, right? So how do we delete a switch? You know how to create one, how to delete one. So I'm expanding this standard switch, vSwitch1, and then there's a 3 dots here against that vSwitch1, right? So if we go there, there's a remove button here. So we need to remove vSwitch1 and the port group that was created within vSwitch1. So just click remove here, and yes, who means not yes. Okay. Anyway, so then we go for vSwitch 0. Now, obviously, we need vSwitch 0, so we're not going to really remove that. We're going to go ahead and remove the extra 2 port groups. But before that, there's 2 virtual machines, or 1 virtual machine in your case, or 3 virtual machines, whatever is the case. To remove the virtual machines that are connected to this port group to a default port group called VM network. In my case, it's your first name VM0, my first name VM01 dash template. Armor VM02 virtual machine is there, and then there is Armor VM02 OVF, Armor VM03 virtual machines are there. Although if we delete the the port group here, it's not gonna delete virtual machines, obviously. The virtual machines will not have any port group to connect to. We need to then manually connect the virtual machines to the this one port group, the default port group. We're not deleting it, right? So what we can do is, yeah, we can just either go to each virtual machine and move it to that VM network, but just to save time, I'm just gonna delete that. Later, we can actually move that in our free time virtual machines to the other port group. So I'm gonna go for VS0, which is virtual switch 0, marketing department, PG or port group. I'm just gonna select the three dots here and move. Okay. So here, and then we're gonna go for VS0, sales department PG, and then we're gonna click. Okay. So remove and yes, it should be something like this. Well, it should be seen as the other hypervisor, which I did not start, so I'm just gonna do the other hypervisor. And our center should detect that. Okay. So the two groups are gone. And why is this coming in? I'm just gonna close this. Okay. Now I'm gonna click this. Okay, so I was waiting for the where it started. So it should be detected as well. E6i3. So I just want to check that E6i2 and E6i3 virtual standard switch zero settings are exactly the same. So I'm just gonna click that E6i03. It takes me to the same page, virtual switches, and configure virtual switches, and then switch zero. Yes, it has two network cards, one VM kernel port and one port group. If I go to E6i2, it has two network cards, one VM kernel port and one port. So we're good. Both supervisors have exactly the same virtual standard switching settings. Suppose I had not deleted switch one and the two port groups here in vSwitch 0, like it's not, it wouldn't have been anywhere disruptive for the vMotion lab. Just wanted to show that they are exactly same. If you're not same, that still doesn't matter. You can still do vMotion. You can still migrate a virtual machine from suppose this hypervisor to this hypervisor and from this hypervisor back to this hypervisor, even if the number of switches, virtual switches are different, number of port groups are different in different hypervisors. So it's not disruptive. Just to keep the environment similar, only for that. Technically, you can still vMotion, right? So let's go ahead and try to talk about
Hello,
the
hello, sir. Sorry.
vMotion. Yep.
Hello, sir.
Yep.
Sorry, I had an internet issue. I think you have deleted the MKT department and sales, right?
Yes.
Okay, how do you delete it, please? How to
So
delete it so as to follow you.
you just have to go to the port group. This one or this one. MKT port group.
Virtual switch.
So are you on vSwitch 0?
I'm the virtual switch.
0 or 1?
Okay, I am.
Jesus.
SXI or what?
So are you in E6i2?
Yeah.
Are you in
Virtual
configure?
switch 0. Yeah,
Okay,
virtual
virtual switch 0.
switch 0.
And then you have marketing or MKD
Yeah,
group
I
as
have
well.
market. Yes.
So
4 of
on
them are
that,
there. Yeah.
yeah, so on that marketing port group, go to this three dots and then click this. Not on this one, the marketing one.
Okay.
That's the only way. I mean, click remove and they will be gone.
Okay, thank you so much.
You're welcome. Okay, so now I'm going to talk about this, migration. So why do we need it? We may have talked about that before as well. Why do we need it? But let's talk about a scenario. So obviously, we're going to create virtual machines, or we will always have virtual machines on the hypervisor. So there's that number of maybe 10, 20 virtual machines are running here, and it's peak hours. And the virtual machines have their virtual disks on the shared disk ones, right? So these shared disks are there. So these are the virtual machine. So VMs, and these are V disks. VMs, V disks. So now what happens is that you get a complaint. Now there are so many users which are connected. Suppose there are 500 users connected here, 1,000 users connected here, 2,000 users connected here, 700 users connected here. Right? So that's a lot of users connected to each virtual machine. Each virtual machine has some kind of application. Suppose it's insurance company, so insurance company related applications are there. There are hundreds or thousands of users connected there. So the users of one specific virtual machine, suppose it's VM I or VM insurance, insurance company virtual machine is there. So suppose the users of VMI machine are saying that it's terribly slow and it's really unacceptably slow. Whatever files we open, it's just too slow, right? So what happens is that you investigate and you see that the underlying hypervisor's CPU and RAM are actually 90% consumed, and it's actually going up to 91, then 92, and then you see that CPU and RAM here on this one is only CPU and RAM here is 50%, right? 50%. Now, you see obviously that this hypervisor has less amount of virtual machines. Suppose there are just 2 or 3 virtual machines, or the virtual machines that are there aren't actually consuming a lot of CPU and RAM, but here majority of the virtual machines are consuming a lot of CPU and RAM. So then you decide that this calls for the vMotion or the migration of the virtual machine from a slow performing hypervisor to a fast, better performing hypervisor. You simply start migration of virtual machines from one hypervisor to another hypervisor. The good thing with that is the virtual disk does not move. Virtual disk remains on this data store. That data store remains on this LAN. This LAN is coming from logical unit number, or the shared disk over the network is coming from a virtual SAN. Right? So that disk, now this one is connected to this hypervisor, to this hypervisor, to this hypervisor. So same shared disk over the network, or one is connected to all 3 hypervisors or all 200 hypervisors. Suppose there were 200 hypervisors. So if the virtual machine puts its virtual disk on this data store, which is on top of this LAN, which is connected to all 3 hypervisors. So whether the virtual machine connects to its virtual disk from this hypervisor or it connects from this hypervisor to its disk, it's going to connect because this LAN is connected to all 3 hypervisors. So wherever the virtual machine is, it's going to be able to connect to virtual disk because this LAN is connected to all 3 hypervisors. That's the thing. So virtual disk doesn't have to travel. Only the memory contents of the virtual machine travel, which are very small in size. Memory content is what? How many users are connected here? What file is open? What kind of activity is going on? that unloads from the memory of one hypervisor and loads on the memory of the other hypervisor. So only the virtual machine content within seconds migrates from this hypervisor to this hypervisor. So when it reaches this hypervisor, there's a cutoff time here. So it was connected this through this hypervisor. This virtual machine was connected to this through this hypervisor. Now it will cut off that connection. It will be in a millisecond. It will make that connection through this hypervisor, this disk one. And how is it able to do that? So cut off from here, and the virtual machine is connected from this hypervisor to the same disk, because it is on a data store. There is on a LAN. That LAN was connected to this hypervisor, and it is also connected to this hypervisor. So virtual machine can still connect to this virtual disk from this hypervisor. Well, what's the benefit of that? Benefit is that the heavy, suppose this disk is actually 100 GB, or maybe this disk is 50 GB. Even a 50 GB disk will take longer time to migrate over the network, and especially during peak hours, no way. And normally the disks or application machines are having disks that could be more than 100 GB, maybe it's 200 GB. Right? So if it is a 200 GB disk has to migrate or move over the network, that's going to take a long time. And that's going to be very disruptive with whatever tasks the users were doing. So thing is, the disk cannot move. If the disk does not move, only virtual machine moves, and the migration happens in seconds. Okay, what about the users that are working on top of it? So the user experience is that obviously they would not know that there's a migration going on, and if they were working on their document, that document will freeze. They will click, and nothing will happen. Document will freeze for 2 seconds, 1 or 2 or 3 seconds. And while they're about to think, call the desktop support, hey, my document is frozen, all of a sudden it starts working. Now the virtual machine is working out of, and the whole connection information was moved also this hypervisor. It has been loaded to the RAM of this hypervisor, which is only 50% used. So 50% RAM is still available. So all of a sudden, after a freeze of a few seconds on the user side, their files will start opening fast. They will start working fast. So they will not care about, oh, it froze for a few seconds. They will now be happy that, okay, well, our documents are opening fine and fast. So that's how the whole migration really happens. It's just the memory content that needs to travel over the network to any of the hypervisors. Suppose there are 50 hypervisors here, right? So all those hypervisors are connected to each one. If the 49th hypervisor is also connected to the same one, the second hypervisor is connected, yes, you can migrate the virtual machine to the 49th hypervisor as well, because as long as you have the same LAN connected to each hypervisor, source hypervisor and the destination hypervisor, migration will be lightning fast. Right? So that's the thing. If the disk doesn't have to move, it's going to be lightning fast. If the disk has to move, then good luck and wait. And it's going to be very disruptive. You can't decide. And it's not possible to move during daytime, during peak times, right? Where do you move the disk? Suppose you have to move the disk. Suppose this store is running out of space. This LAN actually ran out of space or running out of space. And this is very critical virtual machine and critical disk. And you actually want to move the disk away from this data store. Yes, you can do that too. You can move this disk to another data store. In that data store, you have huge amount of free space. Yes, you can move the disk from one data store to another, but if you're moving obviously 100 GB or 200 GB disk, then you need to decide nighttime or weekends to move a disk, because obviously that's going to be very disruptive, or it's going to, if the users are still working, obviously they are trying to open a file from the disk that is actually going through a migration. So that's going to be very disruptive for the end user. So you will only plan moving a disk during the weekend or weekdays nights. So if it's just a virtual machine that you need to move and the disk is not moving, you can do it anytime, provided that you've correctly configured the vMotion configurations. So that's an overall discussion of vMotion, and that the virtual machine memory content has to move, and the disk doesn't have to move. Then it's going to be real fast with users actually connected. Now, that said, now we're gonna start configuring the vMotion related features as and well. And let me just take
I have a concern, please. Hello? Yes, for the migration of the whole disk, for example, to another data store, that will still be done with the vMotion feature.
migration of
Whole disk. If you want to move the
yes,
whole disk, yes, to another
yes,
data store. Okay.
we're gonna do that as well, practically now.
Okay.
So how to do that, how to do this, and how to even do both. So this actually moves from one hypervisor to another, and its disk moves from one data store to another. We can do it in one wizard as well, and we can do it separately as well. So we're gonna do all this. So how to do it? Yeah, we're gonna learn that in the lab now. After we have properly configured the vMotion for the two hypervisors, and let me just grab. That's it. Oh, hey, I was not doing that. YouTube to MP3 converter. Anyway, so yeah, I'll just go for one more doing. Guys, I need to quickly down and load that folder slide that has more vMotion information, so I could share some more points about vMotion, precautions about vMotion. So I'm just going to quickly down and load that. Oh, actually, just very quickly. On the screen, I'm doing that. Just want to share some more points about these. Okay, vMotion and storage, V and motion. So there's an older slide I'll be sharing with you now. And paste. Okay. I'm gonna obviously share that slide with you, but just sharing some points from that slide that are always the same points in vMotion since VMware game. Okay, so now migrating virtual machines, that's another slide here. And T-shoot, yeah, so when we are doing a vMotion, so what happens is that if the virtual machine has a CD-DVD mounted to it, then it's not going to let you vMotion. I think we talked about that before as well. And in fact, I tried to delete that, remove that mapped ISO and then delete the whole CD-DVD, and still it didn't really. So then we use another machine where we never map the ISO of Windows or Linux to the CD-DVD, and that virtual machine migrated easily. So we're gonna still do and try that, but that's a T-shoot, and that's something that we need to know. Other than that, we migrating virtual machines. Yeah, so majority of the things I've already said, and this is something I can. This is the same thing that I'm going to show here in the diagram in this table. So there are types of migration. So there is cold migration, suspended migration, vSphere vMotion, vSphere storage vMotion, and cross-host vSphere vMotion. So that is the cold migration. The virtual machine is actually off. If the virtual machine is off, then you don't need to really be worrying about. Obviously, first of all, you don't worry about the downtime of users. It's already off. No users is connected, right? Now, there's another thing about vMotion, and vMotion or the migration of virtual machine. That process is very sensitive about CPU. Now we see that the whole VMware is so sensitive about CPUs, but migration process specifically is very sensitive about CPU. And what is the sensitivity? Suppose the virtual machine is migrating from one hypervisor to another. So the hypervisor, so this virtual machine is about to migrate from here to here. The CPU has to be exactly the same vendor. So first of all, no-go is that if the CPU is from AMD in this hypervisor and the CPU is from Intel in this hypervisor, so it's not going to work. It has to be the source and destination hypervisor physical processors cannot be different vendors. So that's not going to work. Second thing is, there are two hypervisors and the virtual machine is about to be migrated here. So the CPU must belong, so obviously it's the same vendor, right? So CPU must belong to same vendor, we know that. Okay, Intel, but it has to belong to the same generation as well. So same vendor, same generation of processor. If your one hypervisor processor is from Intel, but different generation from the other hypervisor, then again the migration will not work. So what about that generation? So what is generation? Obviously, suppose you see that in 2012, the Intel produced some processors. In 2013, they did some, they added some advanced, a bit more advanced features in the processor, but their core architecture is still the same. So if the core architecture is still the same, and just slight difference of some features between actually that's 2012 and 2013, suppose, or 2021 and 2022, they are just exactly like the core architecture is the same, but some features different. So they will belong to the same generation. So suppose there is 2018, there was a line of processors that Intel released, and then in 2022 they had a total revamp of the core architecture of processor, and the core architecture is a lot different than the processors released in 2018. So this means that now they belong to a different generation. If they belong to different generation where there's a big difference between the Intel processors, then also virtual machine of different Intel processor generation based hypervisors will not work. So vMotion will not work in that case as well. So it has to be belonging to same generation, which means slight difference of processor features between two hypervisors. Right? So that's why you will see that there's an actual column of CPU compatibility to all types of migrations. Because processors really play a very critical role. We know it firsthand now, how critical processors can be. Now, what about the cold migration, the other types of migrations here? So cold migration is the virtual machine is off, and we don't care about CPU families in both source and destination because obviously they're already closed, right? They're already shut down. So yes, you can move the virtual machine and the disk and it doesn't make any difference. They don't check the compatibility. Suspended means that virtual machines were powered on and then you suspended them, not shut them down, but suspend them. In that case, yes, you can move the virtual machine from one data store to another and host to another host virtual machine and virtual disk. But suspended must meet CPU compatibility requirements. So suspended is like a started virtual machine is in a frozen state. So it whatever state it was in when it was running, so then it is frozen. So even frozen virtual machine movement or migration requires that the processor be of the same generation. It's not exactly the same. There is vMotion. That's the special one that if the virtual machines are powered on actually, and yes, you can do host to host migrations. And across vCenter, yes, you can do across vCenter as well. Shared storage, yes. Now you need the LAN of the LUNs as well, SAN as well, and yes, they must meet CPU compatibility requirements. Then comes the storage vMotion. So storage vMotion is what is the storage? Storage of virtual machine. So what is a storage of virtual machine? Storage of virtual machine is all the files of virtual machine. Okay, what are the files of virtual machine? So when you exported the virtual machine out of the vCenter, so there were 4 files, right? So all the files of the virtual machines, constitute that storage of virtual machine. So the .vmdk, the virtual disk, the .vmem, the memory, right? And then there are configuration files, and then there are snapshot files. VPSD are the snapshot files, and configuration files are pretty easy name, but I forgot the extension. But it's pretty VMX, yeah. .vmx is the configuration file. VPSD. So all these files that are there are actually the storage of the virtual machine. These are the files that constitute storage of virtual machine. So you want to move all these files. Basically, you're moving the whole virtual machine, right? You want to move this virtual machine away from one data store to another data store. That's what I was saying, that hey, the VMDK size, it's a virtual disk. It could be 200 GB, it could be 100 GB. So do it at nights or weekday nights or on weekends, right? So if you want to go for storage vMotion, yes, you can do that. It's just data store to data store, and obviously processor is not really a criteria here. Cross-host vMotion, vSphere vMotion. So that is where you do 2-in-1. So not only that, you move the virtual machine from one hypervisor to another, but you move its virtual disk also from one data store to another. So that is called cross-host vMotion. So we're going to do that. Once we have configured all the configurations of vMotion, then we're going to first do the core migration, then the suspended migration, then vSphere vMotion. Then we're going to go down to cross vMotion. We don't need to really move just the storage of the virtual machine, because we're going to do that together with the virtual machine itself. So these are the 4 types of migrations. And then yes, vMotion is very sensitive about processor compatibility. So now we're gonna configure the vMotion, and then we're gonna actually do the migration of the virtual machines. So let me just seriously, what's wrong with it? So it's all processor compatibility and types of migrations. If we go for some more specific points here, so all the slides would be too much detail here. That much of that we have already talked about. Improves overall hardware. So the benefit of migration. Then it says that from virtual machine A, actually moves the memory content and the memory bitmap. It just gets copied there to the other one, and then the virtual machine gets migrated successfully. There are some requirements as well, or we can say limitations as well. In what cases um, it will not migrate? In what cases? So it must not have a connection to an internal standard switch. So the thing is that it's must not have a connection to an internal standard switch, virtual switch with zero uplink adapters. There can be virtual standard switch with zero uplink adapter. Okay, so that's one thing that I need to I did not discuss there, and that's pretty easy. What does zero uplink means? Zero uplink means that if a virtual standard switch has no physical network card connected at all, is that even possible? If I click the add networking to add another standard switch, you don't have to do that. I'm just showing you next, and I'm creating a new standard switch, suppose, right? Next, and then I actually do not add any physical network adapter here. So if the virtual machines connect to this standard switch, they can communicate with each other, yes, but they cannot communicate to outside world. Their communication will stay behind the switch only with each other. Right? So if I click next here, so it's going to say there are no active network adapters for the switch. Click OK to continue or cancel to review your changes. So if I press OK, it's going to continue. So it's going to let you create a switch that does not connect to a physical network adapter. So suppose I go there and finish, it creates a standard switch. Now this switch, when we go to the diagram of that, you can see that it's a port group, yes, but there is no physical network adapters. On the other switch, yes, there are physical adapters. This switch, no physical adapter. So yes, you can still connect virtual machines to that, but those virtual machines will be able to communicate with each other only. Not communicate to other virtual machines in the other switch, or the product does not leave the switch because there is no physical adapter, right? So this is possible technically, and obviously, if you connected a virtual machine here and you want to migrate this virtual machine from this hypervisor to another, obviously there is no physical adapter. How can you move the files of the virtual machine outside of that switch? There is no physical adapter. That's what it's saying that zero uplink. This physical adapter is also called uplink. There are two uplinks here, right? Uplink. So that says here that into standard with zero uplink adapters, you can't really migrate virtual machine. So it must not have a connection to a virtual device such as a CD, DVD, or floppy drive with a local image mounted. This is what we talked about before. I tried to actually fix it, but not able to do that. Sometimes it gets fixed when you unmap the ISO from the CD, DVD of the virtual machine, which is about to be migrated. Sometimes it does not work. CPU affinity configured. CPU affinity is that CPU affinity is that if you have a virtual machine on top of a hypervisor here, and it has that special CPU, suppose it has a GPU powers graphical processor unit, right? GPU chipset also connected to it, and you have that virtual machine that actually uses a GPU portion of the CPU here. So, or it is the GPU or graphical processor unit, so it supports cryptocurrency, right? So then you can create an affinity to that. So affinity just means that you cannot really migrate the virtual machine away from this hypervisor because it has CPU affinity, right? So we're going to talk about, we will be talking about affinity rules as well. But CPU affinity, if it is there, so obviously you would put that because if you move that virtual machine to another hypervisor and that hypervisor has a normal CPU here and does not have a GPU, then whatever the application you were running here will not run at all. It needs some special power from the processor. So that's why affinity just means that you cannot, hey, migration or vMotion guys, you cannot really move this virtual machine away from this hypervisor because it has CPU affinity. So that's just CPU fee and DT. So if all right, okay, then there is that swap file. So if now swap file, many of you might know the page file in Windows. So swap file is same like page file. So it some space on the disk is being used as memory. That's called swap file in Linux, and that's called page file in Windows. It just says that if you are moving virtual machine from one hypervisor to another, and on the source hypervisor it was using a swap file, that swap file should be accessible on the other hypervisor, or there should be a swap file or some disk on the destination hypervisor should be having swap file space there as well. Otherwise, it's not going to migrate. Virtual machines on RDM, raw device mapping. RDM, raw device mapping. Okay, what is that? So let's and it in. And let us change the color here. This color is not good, very good. So what happens to this RDM here? Okay, what is RDM first of all? So what if there's a hypervisor here, and there are multiple hypervisors here, and they have LANs attached here. So this is these are hosts, host, and host, and this is obviously LANs, right? Now you have some kind of virtual machine here, and that virtual machine is running out of this host, and it has its virtual disk here. Okay, it grabs the other. Okay, so this is a VM, and this is the disk, the disk, that is. And then the users complain that, hey, when we're connecting and saving files to this disk, it's terribly slow. So you then realize that, okay, I need to do something about it. So how about I create, I add another LAN here, and that LAN would be not shared by any other virtual machine. So what happens actually with the regular LANs there, that there's virtual machine running from here, maybe 20 virtual machine running from here, maybe 10 virtual machines running from here, 15 virtual machines running from here. So they all share, obviously, the LAN. So they are all having their virtual disk, on a shared LAN. Obviously, that's why the performance of that would be also affected, because the LAN is being shared by the disk. Disk, right? So that's why suppose this machine is very critical, and it's also using the data store that is on top of one that is being used by all other virtual machines as well. So then you decide that, no, I want to have a dedicated LAN only for one virtual machine. So you add another one here, and then you attach that to where is it? To attach that one to this virtual machine only. Now, this virtual machine has all the LUN to itself. It means that within this virtual machine, you can deploy an application that could actually format the whole LUN as a raw disk. RDM is a raw device mapping. So a raw device mapping just means that a raw disk is made available only for the use of this virtual machine. So when you install an application here that uses the whole of the one to itself, so it's read and write read and write, or we also call it IOPS. IOPS or input output data per second. So it's reading something. Suppose you're doing a search, so it reads the data from the disk quickly and show you the result of the search. Suppose you're saving something, so it writes on the disk and saves your modification. So if there are hundreds or thousands of users doing that, so it's a huge amount of read and write going on. So if that disk is shared by all other virtual machines and hundreds of users are doing the read and write, so obviously it's going to go slow. If only one virtual machine's users are using the whole disk for their own purpose, so obviously their read and write speed will be much, much faster. So the concept of raw device mapping is just that you provide the whole raw one for just one virtual machine. So it could put its data here, and the data read and write speed would be, especially read speed, would be very, very fast. That now it says in the migration that if this virtual machine which is about to migrate, suppose, was having RDM as well, that RDM should be accessible from that host. Suppose this virtual machine is about to migrate to this hypervisor. Wherever is about to migrate, that from that hypervisor, this virtual machine should be able to access the RDM as well. Obviously, it was using that from this hypervisor. So wherever it's going to be migrated to, from there, it should have access to the RDM as well. So if the destination hypervisor does not give access to the virtual machine to the RDM, then yes, you cannot migrate. That's the story. So these are some of the limitations of vMotion or migrate and transition. So let's F1. Oh, that's a lot. Okay, so this one, right? So, oh, what happened? Seriously. Okay, I took a picture of that. Don't tell me I lost it. Okay, it's in the video anyway. Seriously, I lost it. Sorry. I think I copied something else as well. So then that whole diagram was lost, but it's in the video, the backup. That's why the video is always running. So the whole explanation is there as well. Okay, let's keep going. And we were talking about this vSphere vMotion migration requirements. It's more of limitations than the requirements. And other than that, now we need to actually configure that as well. Swap file, we already talked about that. Host requirements for vSphere. So it should have 1 gigabit Ethernet card. And there's another feature called EVC, enhanced vMotion compatibility. That this feature also hides the processor incompatibilities of the two hypervisors. So EVC hides the processor incompatibilities between the two hypervisors for the vMotion process. So if a virtual machine is about to migrate and there's a slight difference of features between the processors of the source hypervisor and the destination hypervisor, then VC is one of those features which simply tells the vMotion, hey vMotion, both processors are exactly the same. Go ahead, migrate. So it just hides from vMotion, or it hides the vMotion from seeing the incompatibilities of the source and destination hypervisor. So EVC is just that feature. I'm going to be showing you that too. Okay, what else? CPU compatibility mask. So yeah, CPU is masked as well, just to hide incompatibility features. So there is also called a feature CPU masking. Then there are some processor feature related abbreviations there as well. That clock speeds and some terminologies there as well. Clock speeds, cache sizes, hyperthreading, and number of cores. So CPU characteristics, and then exact match required between the source and target hypervisor and the reason. So it's all mentioned here. That some of the actual features and characteristics of processors required on the destination hypervisor as well, and some are not required. So these are some of the features that are required on the destination as well. But then EVC is another VMware provided feature that kind of hides some of the incompatibilities of the source and destination processors of the two hypervisors. Okay. So other than that, yeah. So generations. I'm going to show you the EVC later as well, and then CPU baselines for EVC clusters. So it just says that CPU ID. EVC works at the cluster level using CPU baselines to configure all processors included in the cluster enabled for. So EVC basically tries to tell the vMotion feature that hey, everything's okay and all the processors are exactly the same, and go ahead, migrate. That's what they are trying to tell. The cluster requirements, again, it just goes into very in-depth details about if the processor has this feature enabled and that feature disabled, and how EVC just tells the hypervisor that hey, both sides the features are enabled, or on both sides the features are disabled. Go ahead and migrate. This goes a bit more in depth about processors NX and XD features there. NX is no execute and XD is execute disable. So there are some processor related configurations that you can also read on internet. But EVC just shows them as all same to the hypervisor. Then there is that identifying CPU characteristics. So again, it goes in depth. If you start your machine and if you enable the boot process, then you might be able to see. These are on the server level, not on the laptops, but on the servers, big servers, Dell, HP, IBM servers. They do show some extra information about processors as well, if you enable certain options. Okay, so it says that if the ISO is mapped to the CD DVD, then it's not going to move, and that's how the error will look like. Hopefully, we won't see that. And then the whole process of vMotion is put in words there as well. I've already explained that before. You can see it in Word. I'll share the slide. And then so we just need to check extra that what's the configuration of the two hypervisors one by one. So we're going to do that in the lab now. If we go ahead and requirements, we go for requirements. So then these are the requirements that need to be met. Then there are these requirements as well that need to be met. So if anyone's in for a break, then let me know. Otherwise, we keep going and early or something like that. Up to you. Yeah. So yeah, there's that offer. Okay, so let's start configuring bodies or anything. So more break screens. Okay, so you may be looking for when you're ready. So let's configure that. Now here the requirements are that CPU compatibility. Now in our machine, obviously our CPUs for all the hypervisors are exactly the same because they're on the same laptop, same desktop. So we don't have CPU incompatibility issue between these three hypervisors, obviously. That's check. Motion interface, minimum 1 GB adapter. Now, nowadays, all the network cards that are coming have minimum 1 gigabit GB per second GBPS adapters there or more actually. Shared central mass storage. This is, we have SAN or virtual SAN. Yes, we have that too. Same naming for virtual port groups. Yeah, so if I just show you there, same naming of virtual port groups. So our source and destination hypervisors are ESXi2 and ESXi3. Okay? So if I go to ESXi2, configure virtual switches, and the port group is VM network, the name of VM network. Okay, so if I go to ESXi3 to the same view, configure the switches, yes, it also has a VM network port group. They are same name port group. Yes, we are good, but okay, it's not compulsory to have same name, same named port group. Suppose the name was actually different. Here in source it was sales group and there it was marketing port group. It's still going to be able to migrate. It's just going to show you, hey, your destination network is a little different. Go ahead and check, and you can ignore that and keep going, and it's going to migrate. Okay, sufficient resources on the target host. Obviously, you should have sufficient CPU and RAM available. Essentials plus license or more is required for vMotion. Yeah. Okay. So now here we have our CPU requirements are okay. We have same CPU for our both hosts. Let's confirm our network settings. That's where we need to actually do configure. We're gonna be adding a VM kernel adapter. Remember that VM kernel adapter or VM kernel port is that feature of virtual setup switch that offers networking to advanced features, advanced components of vSphere. So we are about to deploy vMotion, which is a very special feature of VMware. So for that, the network settings has to be provided by VM kernel adapter. Okay, so we're going to be configuring, the two hypervisors ESXi2 and ESXi3 for the vMotion now. In order to do that, we have to create a VM kernel adapter and enable vMotion on the hypervisor level. So how does it all happen? So we're going to do that now one by one on each hypervisor. I'm just going to go ahead and add VM kernel adapter on hypervisor ESXi2. Then I'm going to add the VM kernel adapter on ESXi3. Go back there, and I'm on ESXi2 because I want the virtual machine to migrate from 2 to 3 and back from 3 to 2. All right. So I'm going to go for ESXi2, and inside the ESXi2, I'm going to go for, you can see this VM kernel adapters here, right? So ESXi2 configure networking under virtual switches VM kernel adapter. So I'm just going to click that. VM kernel adapters, there is VMK0 management network, vSwitch 0. So there's already one VM kernel adapter, and we talked about that it introduces a special feature called, or important critical feature called VM network, management network. And thanks to management network VM kernel adapter, we are able to remotely connect to a hypervisor and manage it. So now we're going to go for adding another feature, critical feature called vMotion. I'm going to click the Add Networking option here. So I'm just going to click the Add Networking. Okay, guys, one more thing is that we're going to do it, we're going to configure it in vendor best practices way. So what does vendor best practices say about configuring the VM kernel adapter? And I'm going to show that by a diagram here. Okay, now there's a lot of traffic going through vSwitch 0, right? Now, if we add the VM kernel adapter and vMotion feature, so virtual machines will be migrating from one hypervisor to another. The vMotion traffic will also go through this standard switch, through this one or two network cards, then go to the other hypervisor. How about we want to, obviously the virtual machine regular traffic is also going through the same virtual standard switch and same two network cards. Why not we separate the traffic of vMotion from the regular traffic? Regular traffic is going through the vSwitch 0 and these network adapters. So currently what our environment or any typical environment will be configure and do, and that is this. So these are the two network cards that are connected to this vSwitch 0. So, oops. So why don't we just create an other virtual standard switch in the same 6i0? So this would be another standard switch here as well, and that would be obviously the switch name is automatically given by the VMware, so it would be vSwitch 1. The good thing about vSwitch 1 is, or any other separate switch, the good thing about that is, okay, so that's how it currently looks like, right? So two network adapters are already connected to the vSwitch 0. What we're going to do is we're going to introduce another standard switch just for the traffic of vMotion, and it will have its two network adapters. So the vMotion traffic will not overwhelm the traffic of the regular traffic of the virtual machine, right? So that's the best practice. So that's why it's supposed to have 4, 8, 12 network adapters in a typical physical server that has hypervisor installed on it. So more network cards, better traffic management you can implement. So if we regulate the traffic like this on vSwitch 1, and then the virtual machines are now those virtual machines that are connected will be connected to, so suppose the virtual vMotion is configured only on vSwitch 1. It's not configured on vSwitch 0. So any virtual machine that are about to move, they will actually use vSwitch 1, and the traffic will go through its own specific two network adapters through that, and then they will enter wherever vSwitch 1 in the other hypervisor should also be configured with vMotion, and vSwitch 0 is not configured with vMotion. So this means that the vMotion traffic only travels through the second switch with their own preferred, with their own dedicated network cards to and from the two hypervisors or 200 hypervisors. So the thing is, just to separate the traffic, you need more network adapters. And if you have more network adapters, you can create extra switches and connect few network adapters to one switch and network adapters to the other switch and the third switch and so on, just to separate the traffic and keep the bandwidth under control. Right? So that's what we're going to do. We're going to actually use two network adapters, a separate switch for the vMotion feature. All right. Okay. So copy this. We separate the switch and do next for Vimo and done. Oh, the photo doesn't increase the fonts. Okay, yes. So let us go ahead. Let us. So what we did was we were on the ESXi2, configure, VM kernel adapters, then we click add networking. And when we are here, we have decided to go for creating a new standard switch. So we're going to go for the middle option here, and we're going to click next. Then it says you want to select an existing switch. No, we say that we're going to be clicking new standard switch and click next. Now we're going to go for the next two adapters. Remember that we added 9 separate adapters. So now we're going to take benefit from them. So I'm going to click plus sign, and the next two adapters are VMNIC 2 and 3. So I'm going to select by pressing shift the second network adapter as well, and press O and K, and then click next. So for the port group, so when you create a switch, obviously it will create a default port group with it, because the only purpose of switch is to connect virtual machines, right? So we're going to name that port group as what's going on here? Something VM kernel adapter on a new switch, right? So just a sec, guys. VM kernel port on a new switch. It's not showing those options of oh, sorry, guys. Wait. Back. We will be creating new standard switch, but we're going to go through this option. Sorry. VM kernel network adapter. We are creating a VM kernel adapter, right? So yes, we will be creating a new switch, but from here. This will create a standard switch with a standard port group. So this option will create VM kernel adapter, as the name says. So sorry about that. Let's click the first option and click next. And now it says, hey, you want to enable vMotion on available existing switch, or you want to create it on a new switch. So if I go for new switch here, select an existing switch, this one. So new standard switch, right? Now, new standard switch, and click next. Now I'm gonna just go for the next two available network interface cards. Shift and click on the mouse for the second adapter as well. It's okay. And then I'll click next. Now these are the options that I was looking for, and then I was thinking, whoa, where's this option? So here, network label, I give vMotion as the name. And VLAN ID, no, I'm not VLANing it. IP settings, it's just V4, not V6. MTU, I don't want to change the MTU. There is another feature here called TCP/IP stack. Now this feature says that, hey, if you're configuring vMotion on this switch, so I'm not going to let you configure any other advanced feature that has its own lot of traffic as well. So technically what you can do is, suppose I don't select that, suppose if I select that, you can still click any of those other options as well. We're not going to select those options, right? But I'm just saying that these are also some of the advanced features. And so vMotion generates its own migration traffic. But If you want to introduce fault tolerance, so fault tolerance creates its own traffic. Other vCPUR replication creates its own traffic. So this means that technically, yes, you can configure all other advanced features on this VM kernel adapter, but then the network adapters, network cards connected to this switch will be overwhelmed with migration features, fault tolerance features, vSphere replication features. So maybe two network cards are not able to take that kind of traffic, and the whole traffic and whole functionality will be disturbed. So for vMotion and provisioning is just means deploying. So these are the two features that it says that, hey, I'm going to dedicate this whole VM kernel adapter and the two network cards only for vMotion. So if you select that, now you can see motion is selected, but you cannot select anything else. It means that vMotion feature creates enough network traffic that it's not recommended to then select other advanced features on the same two network cards connected to this VM kernel adapter. So if I don't select this, then yes, I can select others as well, which will be not recommended, but technically, yes, we can do it. So I'm going to go for vMotion just to follow vendor best practices, right? And then click next. Then it asks for, hey, so yeah, VM kernel adapter always requires its own specific IP address because it's regulating a lot of traffic. So VMware has a separate IP address through which traffic could go, and then that kind of traffic could be tracked, that where it is originating from, or which IP is receiving only vMotion traffic, right? So we can receive that IP from DHCP as well. Let's just go for static IP because it's critical traffic, and we don't want to depend on the DHCP for that. So we can use that IP address which we haven't used in this network before. So I could just try to go to DNS and confirm from there as well that till what IP we have used and what are left. Although there's a big range left, I'm just going to go to DNS. DNS is already open here. And in fact, I'm there. So yeah, the server expand, forward lookup zone expand, and then first name hum.local. If you click that, then you see whatever IPs you have used till now, the static IPs. 1, 2, 3, and 4. Okay. So 5, 6, 7, 8 are all available. So this means I can use 5, 6, 7, 8, then 11, 12 onwards. So I'm going to go for 6i2 vMotion setting. I need to give some kind of IP that has never been used before. So 5 and 6, I can give IPs 5 to E6i2, 6 E6i3. So I'm going to go for 92.168.200.5 because it has never been used in this network. Tab 2.5.2.5.2.5.0. Nothing else. So I'm going to just give this new IP to the adapter and click next. So we have configured vMotion on 6i2. We're going to do this exact same thing, different IP on 6i3. Suppose you had 200 hypervisors. You want all 200 hypervisors to take part in the vMotion activity as well. Then you will have to do this on all 200 hypervisors. And I click finish. All right. I'm going to do this exact same thing with obviously different IP on E6i3 as well. I'll go to E6i3, configure, VM kernel adapters, and yes, VMK0 is already there, but I'm going to go for add networking. VM kernel network adapter, I'm going to select that. Next. We're going to go for vendor best practices, although we could have configured it on the existing switch. it overwhelms the traffic. I'm going to click New Standard Switch. Next, add two network adapters. So VMNIC 2 and 3. Another thing about that, suppose VMNIC 2 and 3 you selected on ESXi2. Okay. Now here, suppose VMNIC 4 and 5 are available, but 2 and 3 are not available. So it's okay. It doesn't have to be that 2, 3 network adapters 2 and 3 were available there, so they have to match here as well. No, it could be 8 and 9 here as well, and it's gonna work. But for configurational consistency, it's better to have the same matching configuration. It's good for troubleshooting later, and if you want to apply some big configuration centrally, then all hypervisors should be configured the exact same way. So 2, 3 here as well, and press OK. And next. Okay, so vmo and motion network label here as well. VLAN ID, nope. IP setting, same. V4, MTU, no, I'm not changing. So I'm gonna make it this TCP/IP protocol or stack just for vMotion, so no other advanced feature should be enabled. So we will only have a traffic of vMotion on these two network cards on this switch. Next. Yep, we're gonna go for the network adapter, the used IP, static IPs. 192.168.200.6 tab 255.255.255.0. All right, and next and finito. Now we have the exact same configuration on both hypervisor ESXi2 and 3, but we need to see other requirements, prerequisites for vMotion before we could actually start testing migration across the two hypervisors. Okay, so now once that is done, so I'm just going to go for the check of the previous, but before that, two screenshots now come here. If I go to ESXi2, then configure VM kernel adapters. So we are seeing the two VM kernel adapters. Obviously, the one that we created is here. So screenshot number 1 is like vMotion setting on ESXi2. Screenshot 2 would be vMotion setting on ESXi3. So screenshot 2 first, screenshot 1 of ESXi2, right? So I'll just take a screenshot here. And that would be screenshot 1, vMotion setting on ESXi02. That's the label of, what is this? Okay. Of the screenshot. Motion setting on ESXi2. I'm going to do the same for ESXi3. So for that, I'll just paste it on the WhatsApp group. And screenshot 2. Right. Go back here and ESXi3. I'll go for and go for this line. Obviously, it would be V motion setting on VSXI03 and the screenshot. Like, yeah, this is one of the most important settings. The VM current adapter should be correctly configured. What's the screenshot? All right. Now, what do happen is so now we're gonna go for the slide, and there you go. So yeah, this is done. CPUs are good. Network setting is good now. Make sure switch one have two port groups, one port management. Yeah, we have that already. Two port groups are there. One VM current port, the other one is actually the port group. Remove all the virtual switches. Yeah, we did that. Make sure our VM has an operating system. Like, it's okay to have an operating system with 2012, 2019, 2022 operating systems. Like, it's with an operating system, yes, it's going to work. If you don't have the ISO of Windows mapped to the CD DVD of the virtual machine, so it's going to work. But we're going to try with and then let's create a new data store on our shared storage or ones. We have 3 data stores already, so that's also done. Let's move our VM with OS installed to this new data store, only storage migration. Yeah, we're going to do that too. So now what we need to do is this. We need to check these 4 cold, suspended, vSphere vMotion, and crosshost. Crosshost also includes the storage. It also includes the vMotion. So the special one is the vMotion that requires, beyond virtual machine beyond. Let's just go for the cold migration first. We're gonna keep migrating back and forth between 2 and 3 hypervisors. That's the only 2 we have. Test. Okay, so the machine is shut down. It's on ESXi2. I just one machine here, and I'm gonna right click here, and there's a migrate option. Cold migration, right? So it is off. And then change compute resource only. Yeah, we're changing compute resource. Compute resource is the hypervisor. And next, it shows the destination as well. So we're all good. It's a 3, 2 to 3. So I'm just going to select 3. And it says compatibility checks succeeded. I click next. Okay, so it says network interface. Actually, it detects the old port group settings because this machine was actually connected to that port group that we deleted. So that's why it's showing this. So it says that, hey, this virtual machine was connected to this port group, and destination is this port group. And then it says here, network interface network uses network which is not accessible. So obviously it's not accessible because the VS0 marketing was only on ESXi2, and that it is deleted right now. So we need to go back to this machine, go to the network settings, and change its network settings from this deleted port group, the one port group that we have already by the name of VM network. Let's cancel from here. Basically, this virtual machine is not connected to network at all. I'll migrate that, right? I'm just going to right click here and go to the edit settings. I need to just move it to the working port group. That's all. Edit settings. and there's the network adapter of this virtual machine. So yes, it's on a wrong port group, which actually does not exist anymore now. It's still showing here. So I'm going to select that, go to browse. We have done that before as well. And yeah, that's the only port group we have. So I'm just going to select VM network and press O and K. Now we're good. Now this machine has a network O and K here as well. And we will be trying the migration again. I'm going to right click here, my and rate. It changed compute resource only. Yes, that's what we're doing. Next. Again shows the destination. I'm going to go for E6i3. So far so good. I'm going to go for next. Now it has the correct port group on source network and destination network. And it used by one VM, one network adapters. Yeah. It says that virtual machine uses network VM network since the operation is being conducted across data centers, right? Across data centers. This network might be the same network on the source and destination. This is because network names are only unique within a data center. So they're just saying that, hey, you're about to move a virtual machine from Toronto data center to New York data center hypervisor. So just make sure that network is okay on the destination data center. You know that it's okay, so no problem. Next, we can ignore this warning. And that's it. So I'm just going to click Finito. And yep, so the machine migrated from ESXi2 to ESXi3. Okay. Now we're going to do the second migration, which is suspended migration. For that, same machine we're going to power on, and we're going to suspend it. Then we'll migrate it back from 3 to 2. Right. I'm going to right click and power on the machine. Power on. Okay, it's power on, and then I'm going to suspend it. Right click, power, and there's a suspend. Suspend. Yes. Okay, so now it's suspended, but its green play button will change to the yellow vertical equal signs. Still suspending. So yeah, you can see the vertical yellow equal sign. This is suspended. And now I'm going to migrate it from hypervisor 3 to hypervisor 2. So it's the same process, right click. Now, obviously, the processor, if they're same, then it will work. Otherwise, it won't work in a production environment. I'm going to go to the migrate. Change compute resource only. Next. This time our source destination is 2. Next. We're going to ignore that going across the data center, so we're okay. Its port groups are same. Next. And finito. So it migrates successfully again. All right. So now we're going to go for Suspended is done. V-square V-motion. So let's go for V-square V-motion, where we're going to just simply resume the machine and just keep it powered on. Then we're going to migrate. That migration is the same as in a production environment, the machine is powered on and end users are actually connected to it, and then you migrate the machine. So pretty much that's what we did configure in our environment is exactly what you need to configure in production environments as well. Nothing different. Okay, so we're gonna go again. This time we're gonna power on, right? So that's the same machine. Right click. We're gonna go power on. Now it's just gonna power on and stay powered on. Green button is back. It's powered on. We're pretending that it has an operating system with VMware tools installed, and then there are some users remotely connected to that as well. And then decide to actually migrate the virtual machine across the two hypervisors. So I'm going to right click here and migrate. Let's change compute resource only and click next. Three. Power destination is 3, and no guest OS heartbeats are received. Either the guest OS is not responding or VMware tools is not configured correctly. So it does give us a warning that you're going to migrate a powered on virtual machine to the next hypervisor, but we don't really receive the proof of VMware tools being installed on the virtual machine. So yes, it's an empty virtual machine. So if it had an operating system with VMware tools installed, at least this warning would not have come. But with or without an operating system, the configurations are same and it migrates the same way. I'm just going to click next. And then it just gives the usual warning. Yes, it's okay. Next. Now this time it says that, okay, it's a powered on virtual machine. So do you want CPU priority given to this virtual machine when it is moving, because it's powered on, so it might need some more speed because it's powered on. So this means that users might be connected there as well. As fast as possible, you need to move this machine to the other hypervisor, or you can schedule it. Suppose it's not gonna have CPU scheduling high priority then. So we're gonna just say that, hey, give the most CPU to this operation. Okay, next. Then it's just finished. Okay, it's trying. Thinking. Still thinking. And move, yay! Okay. So yeah, it's powered on virtual machine moves. We need to check two-way migration. So let's move back as well. Obviously, if it migrates there, then it moves back as well. Like if you migrate back, it's pretty much the same process. So let's go for the next one. And that is cross-host vSphere motion. So that cross-host will also include the storage vMotion, or how to move the files of the virtual machine from one data store to another. So we're gonna again right click and migrate it back from host 3 to host 2. I'm gonna right click here and go to migrate, but this time I'm gonna go for the third option. The third option actually includes change both compute resource and storage. So change storage only would move the files from one data store to another. but change both compute resource and storage as the first one and the second one in one go. So it will ask that which data store do you want to move the virtual machines files. So we need to also know before we even start this, we need to know that currently which data store the files of this particular virtual machines are. So we could select then a different data store during the visit. Right, so I'm just going to go back to cancel to know which data store this machine is on. So on the right side, there's a data stores written here. I'm just going to click that. So in my case, virtual machine files are residing on LUN2, DS2 LUN2, right? So it's DS2 basically. So I can choose DS1 or DS3. And obviously the hypervisor is the other one. So both things will change now. Hypervisor will change and the store will also change. So I'm going to right click here, go to migrate, and change both compute resource and storage. I'm going to go next, and so obviously it's compute resource only, and I'm on 3, which is US. So I'm just going to go to Canada and then Tor DC, and then I'm going to select ESXi2. It's the destination. Yes, it's going to go across the data centers, and it's the destination. Here, I'm going to click next. Now we know that it's currently residing on DS2. Suppose I just still click DS2, and the previous versions of VMware, they used to give error here that, hey, you're supposed to migrate away from this. So choose some other data store. But now, I don't know why it just says temporary checks. Succeeded. So I'm going to go for DS3 for no particular reason. I could have chosen this one as well. Same thing, right? So I'm just going to go next. And yeah, it just says the regular thing about the networks and across the data center. So we say, yeah. Next. Let's give us the highest priority, CPU priority for vMotion process. And next. And now we need the storage. Destination is DS3 and host compute resource destination is ESXi and 2. Okay, so this is going to click fee and niche. Wow. All right, finish. So it's going to change both. So this virtual machine should land here, and this DS2 should change from DS2 to 3. Good. So thinking, guys, if this virtual machine had an operating system, obviously it's going to take much more time because whatever the size of the operating system, 12 GB or 13 GB, it's moving that from one data store to another. So thinking. Maybe my virtual machine actually had an operating system because VM01 had an operating system, as far as I remember. That's a lot. It's 72%. Okay, 100% done. Oh yeah. Yay. So VM01 template moved from ESXi3 to ESXi2, and DS2 changed to DS3. Data store also changed. So that's a good migration. So yeah, that's the whole migration topic that we're talking about. And so migration is actually successful in all its forms. I'm just going to shut down this machine. We're off. Okay. So the next topic is a bit bigger topic. It's the distributed switch topic, and we have half an hour because of no breaks or early release. Half an hour. Are we going to do this or not? I'm just thinking. So distributed switch. Okay, let's check it out. We just quickly do that. right, so seems like everyone's sleeping. So quiet. I also feel like I'm sleep talking. Okay, it's too quiet. Anyone even listening to me? Oh, we're listening. Okay, there you go. Sign of life here. Sign of life, guys. Oh, two signs of lives here. So this means Mars has. Okay, three. Okay. Oh yeah, I thought I was on Mars, but it's actually I'm on Earth. So that's been good. Okay, let's go ahead and distribute virtual switch here. Now a distributed switch is a centrally managed switch. And vSphere distributed switch acts as a single virtual switch across all associated hosts. This allows virtual machines to maintain consistent network configuration as they migrate across hosts. So this is, distributed switch would be a central switch that actually lives on vCenter, inside vCenter. So then how does the diagram explains that? Uh, distributed switch. Maybe I'll try to cover the theory because theory is more longer a bit. And the break I needed, I didn't get it, so I'm like now really dropping down. So yeah, by 9:30 we can cover. We'll do that. Distributed switch, and then we're gonna continue in next class. Distributed switch here is first of all it gets installed inside VCSA, so it lives here actually. So we can also call it VDS, which is virtual distributed switch. So we can say equals VDS, virtual distributed switch. We can also call it DVS, distributed virtual switch. So anyway you want to call it DVS or VDS, so it's like that. Now, virtual distributed switch lives here, and so that's the first big difference between standard virtual standard switch and virtual distributed switch. Virtual standard switch is always inside a hypervisor, and distributed switch is actually inside the vCenter. And then the main purpose of distributed switch would be to manage the networking of according to its capacity, is the networking of thousands of virtual machines. That is its main purpose. Suppose you want to change the networking of, so suppose there are 5,000 virtual machines in a big environment, and you want to change the port group of all 5,000 virtual machines. So manually, if you start doing that, that's going to take long time. But you can do that with the help of virtual distributed switch or distributed switch, right? So distributed switch in one wizard and change the virtual network settings of virtual machines from one port group, but all the 5,000 virtual machines can be moved to the other port group in one wizard. So it's just 2 minutes. You can do the work of many hours. So because of distributed switch. How does it connect to all the hypervisors? If I go back here, so from the perspectives of VMs, the VDS is the same as the VSS or virtual a standard switch. So virtual distributed switch is same for virtual machines. It's just providing network. This just provides the network. VDS also provides the network. It's just that we can control the networking of thousands of virtual machines with the help of a distributed switch, while standard switch, the virtual machines networking on the particular hypervisor, one hypervisor can control the networking of. But if there are hundreds of hypervisors and thousands of virtual machines, then distributed switch does the job. So identify vSphere distributed switch capability. VDS acts as a single virtual switch centrally managed across all hosts through vCenter. So we're going to install the distributed switch inside vCenter. VDS offers reduction in management and complexity. Obviously, when large scale machine networking needs to be moved, changed, modified, and it's complex operation. VDS is also known as DV switch, has DV port groups and DV ports. So distributed virtual groups and distributed virtual ports. We can call distributed switch as VDS or DV switch as well. So obviously it will have its distributed port groups and distributed ports, virtual ports. Separation of data and control planes. So it can support other Cisco switch, Cisco Nexus virtual switch. So Cisco also created its virtual switch series, and yes, the distributed switch supports that too. Available in vSphere Enterprise Plus. So that's the topmost license, most expensive license of VMware. So that's obviously the big environments would want to have a distributed switch. So identify vSphere distributed switch capabilities, total virtual network switch ports per host, VDS and VSSS ports, 4096 total ports, total virtual machine connections are supported by a combined distributed switch and standard switch. Maximum active ports per host can be 1016. Static dynamic port groups per distributed switch is 10,000. So remember that we created port groups there, two port groups we created there. So on distributed switch, you can create 10,000 port groups. Ports per distributed switch, 60,000 ports. So one port, one virtual machine, right? So 60,000 ports means it can support up to 60,000 virtual machines. Actually, the latest VMware version, the 7 version till now supports 40,000 maximum virtual machines, but distributed switch can take more than that. Distributed switches per vCenter. One vCenter can have 128 distributed switches. If I create just one, it can have 128 distributed switches. Distributed switches per host. Each hypervisor can take at least maximum 16 distributed switches actions. So every hypervisor can take that. Recap what is standard switch. We talked about standard switch. We don't need to really repeat that. And then distributed switch architecture. It's installed in the center. Yeah. So yeah, we talked about that already. But there are some specific configurations for distributed switches. There are uplinks. Uplinks connect the vSphere distributed switch to physical network adapters on associated hosts. Each host can connect one physical network adapter to a vSphere distributed switch for each uplink port on the vSphere distributed switch. So okay. Now let's talk in English. So what does it mean? So there's a diagram that I already had created. And I hope I saved it in my collection of diagrams, and I did not. Seriously, we have to create that again. All right. So let me add it here. Okay, let me just create that distributed switch diagram and it explains some more. So here, right. So if we have a V center here, and then we have hypervisors here, and that's the V and center. It's obviously a VCSA. And inside the V center, we have distributed switch. So distributed switches here, and it has uplinks or network adapters. Now, each hypervisor here has, obviously, these are ESXi01 and 02, 03, and onwards. Obviously, we're talking about very big environments that can actually afford it. So we have those 01, 02, 03, 04, and 6512. So and they have the network adapters. So suppose each one has um, network adapter here. So there is one network adapter, second network adapter, one network adapter, second network adapter, and one network adapter in second. So now what happens is that those network adapters were connected to the local standard switch, right? So this was the V switch 0. So V switch 0 of all those hypervisors. And this is physical NIC, NIC. Okay, now, and yeah, that's also NIC. Now, what happens is how distributed switch can connect to a hypervisor. So that's the most important thing to understand is that basically they have connectivity. Who have connectivity? Basically, these network cards are connected to the virtual standard switch, right? And they are getting all the local virtual machines are connected to this. But if you want to change that, then this can happen as well. Like the changes. So the change, what is a change? First of all, how can you connect distributed switch to these hypervisors? So you can handle the networking of the virtual machines of these hypervisors, from centrally from a distributed switch. So there are virtual machines here, virtual machines, virtual machines, virtual machines, right? Those virtual machines are all connected to the local standard switch. So these virtual machines are connected to the local standard switch, but you want to control the networking of all these virtual machines, not through the local standard switch, but through the distributed switch. So if you want to do that, then you have to create actually, there is a feature called uplink here in distributed switch. And what it does, it says that, hey, so uplinks are network cards of the distributed switch. But when we create distributed switch, you will see that how many uplinks you want. So we're going to go for 2, we can go for 3, 4, 5, 6, 7, 8. They're just network card connections. So what happens is that distributed switch makes communication with the virtual machines of each hypervisor by connecting its one uplink to the one free network card of each hypervisor. So uplink 1 will connect to the one network card of each hypervisor. Uplink 1 will connect to the network card of each hypervisor, right? So suppose you want a backup network connection from distributed switch to all the hypervisors, and suppose all the hypervisors have actually 4 network cards or 6 or 8 or 10 network cards. So you could have uplink 2 connect to each other network card of the hypervisor as well. So with the next network card, so suppose there was a traffic going from, there were some commands that distributed switch was giving to all the virtual machines through uplink 1, and somehow uplink 1 is unable to send that data, it's down. Then from uplink 2, those same commands can be given to all the virtual machines of all the hypervisors. So that's how, distributed switch gets connected. So there may be more network cards here that are available for still the local standard switch, or you don't want local standard switch to play any part in communication of the virtual machines, networking of virtual machines. So in that case, just you can handle the all tasks to the distributed switch as well. But the main thing is that how distributed switch makes communication distributed switch VDS DVS. It's pretty much the same thing. Same thing. Okay, so the thing is that distributed switch connects to each hypervisor by connecting to one of its three network adapters. Okay, Moise says in the chat, can we use one physical link to connect both virtual switch and uplink? No, that's the thing. Either both virtual switch and okay, so either this physical NIC will connect to virtual switch, or this physical NIC will connect to distributed switch. So this physical NIC cannot connect to distributed switch as well as virtual standard switch. So yes, the diagram might be actually misleading. So that was just to explain at the start. But if it's connected there, in fact, this diagram, this virtual standard switch can be connected to the other two available standard switches, or the other two network adapters, which are free and not connected to distributed switches. So yes, if distributed switch is connected to any network card, that network card should be free. Which means that network card should already be not connected to a standard switch, or well, should not be connected to a standard switch. I mean, distributed switch will only connect to a free network card hypervisor. And so that's why, yes, suppose virtual standard switch was connected, then disconnected from there, or move the connection of distributed switch of the network card away from standard switch towards distributed switch. So yeah, we can do that migration, and I'm going to show you how. But yes, we can actually move the connection of physical NIC from real switch to distributed switch. It cannot be connected to both. Okay, so distributed switch makes that connection to the hypervisor if there's a free network card available. And one uplink of the distributed switch has to make connection with one free network card of each hypervisor if it intends to control all the virtual machines of all hypervisors. So that's how it gets connected. Then there are many other features of distributed switch as well. First of all, I'll save this diagram now because I thought I had saved the diagram before my OneNote. And I used to use that in next classes, but I didn't find that. It's so strange. All right. So now this is the distributed switch related stuff, and I'm going to put that here as well. Well, I'm going to share the other side as well. Okay. Uplinks connect the vSphere distributed switch to physical network adapters on associated hosts, and each host can connect one physical network adapter to a vSphere distributed switch for each uplink port. So, yep, one physical adapter to each uplink port. So that's how it is that the distributed switch makes connection to all the hypervisors. And the virtual machine NICs can connect to vSphere distributed switches through distributed port groups, which aggregate multiple ports under a common configuration and provide a stable anchor point for virtual machines connecting to a labeled network. So what it basically says is that virtual machines will then have connection not to the standard switch, but through the network card to the network card to the distributed switch. Obviously, they have to connect to some kind of port group. So distributed switch normally has distributed port group to which the virtual machines connect with the help of the network card. So they still connect to the port group and not directly to the network card, but they see that as distributed port group instead of standard switch port group. So that's what they are saying here. It's like a group policies. It's like a group policy. It's like group policies in Microsoft. If you have ever dealt with the group policies there, that centrally you can control. So that's what it is here as well. And then that is PVLANs or private VLANs. So distributed switch also support private VLANs. So now these private VLANs. So you must have heard about VLANs that they separate the traffic. VLAN 2 connected virtual machines or physical machines cannot communicate with VLAN 3 connected virtual machines or physical machines. So private VLANs are just VLANs inside VLANs. So they further divide a VLAN. Suppose VLAN 2 has virtual machines and VLAN 3 has virtual machines. So VLAN 2, which has 10 virtual machines, you create another private VLAN inside VLAN 2. Then you divide 5 virtual machines in one private VLAN and other 5 virtual machines in another private VLAN. So you can just further dissect a VLAN with the help of private VLANs. So distributed switch supports private VLANs as well. Then there is NetFlow. NetFlow is a protocol that allows you to consolidate individual packets into flows, to identify where the traffic is going, where the traffic exists, to determine the health of your system. It is only available in distributed virtual switch. So NetFlow is a protocol that allows you to consolidate individual packets into flows to identify where the traffic is going. So it just tries to collect information with the help of collecting by consolidating or combining the packets into flows. So it could know that where the traffic is going, where the traffic is coming from. So it's kind of flow is kind of monitoring and analyzing that few packet it just collects and then tries to put them in flow to and then checks that flow that okay, the traffic is heavy, traffic is big, traffic is the bandwidth is really out of control, or it is very low, it's very high. So it just tries to check all that NetFlow. So yeah, NetFlow feature is available in distributed switch. And there is LLDP, link layer discovery protocol. You have a network devices that need to be able to speak with each other and figure out exactly what your network topology is and where the ports may lie. Your network engineers may need to have LLDP, link layer discovery protocol support, built into your virtualization infrastructure. That their networking equipment. So which networking equipment it's talking about? It's talking about the physical network equipment that can discover virtual network equipment. So if you have outside physical switch or switches, and those physical switches have that LLDP configured there. So my switch, right, physical switch. So those switches run link discovery protocol. So that is if you have BDS installed there. So yes, it will support that kind of discovery. And through VDS, they will communicate and ask that, hey, how many switches you have, standard switches you have, networking equipment you have, network cards, connectivity, how much ports are there. So link discovery protocol is just physical switches trying to discover the virtual network. Right? So yes, distributed switch supports that. Network area control is allows us to take a bunch of different network connections individually and bond them together and then slice and dice the available bandwidth too, so that one type of traffic needn't necessarily overwhelm the other type of traffic. So IO control just controls the input and output of all that data. So suppose there's an email traffic coming from a virtual machine. Suppose there's a SQL server traffic, database traffic coming from a virtual machine. So email traffic should not be able to take 95% of the bandwidth and should not be able to occupy, and overwhelm its traffic over the network. So control just tries to make sure that any one type of traffic does not occupy the whole bandwidth. That's exactly what it does, and it tries to make sure that all different types of traffic. So port 25 traffic, it's email traffic, right? So port 1433 is database traffic. So all that kind of traffic is having enough bandwidth and equal level of bandwidth is made available. So network area control does that, and it's available in distributed switch. And other than that, there's LACP. So there's this aggregation of protocol. It's link aggregation control protocol. LACP was what? Bond together multiple network adapters, but was aggregation control protocol, right? It's a abbreviation for that. I think the Cisco guys would know that, but a simple Google search would tell me as well. So LACP, link aggregation control protocol. Yep. Okay. Oh, was it correct? It is a link aggregation control protocol. Right. So let's go ahead and try to not make you sleep, because everyone is look like sleeping, including me. No, anyway, so let's go for LSCP, and there's the link aggregation control protocol. What it does is starts at the physical networking side, but allows you to bond together multiple network cards for the support of load balancing. So you want to aggregate ports to send traffic in a load balanced manner, and you use this protocol, and distributed switch supports that. The difference here with LSCP is that there are some additional configurations that are required both here in vSphere as well as on the network equipment. So it's Cisco equipment, it's Juniper equipment, and network equipment has to support LSCP as well. So yeah, so then you can do some port load balancing as well. Now, other than that, yes, you can do backup and recovery of whole distributed switch configuration as well. So when we are doing the configuration of the distributed switch, so at that there's an option for backup and recovery as well. As the lab is much longer than what we have time for, and we also did not take a break, so this means that now we have two screenshots, so you can upload, and we're gonna do a brief intro again to this distributed switch in next class, and then we're gonna start doing the lab right away, and then we're gonna go for even more critical topics like the clustering and HA and DRS. Okay, so go ahead and upload your document screenshots on the folder that I haven't created yet. Okay, just do it now. And we're going to continue with this topic. All right, so I will go for the creation of the folder, and then you can and load. What? It keeps coming. Oh, one is me to read all. Okay. I don't know. Okay, I'll just stop the recording now at least.